I'm going to add an sort of another perspective of what we just heard. So my background is software and DevOps, continuous delivery. So when I look at some things, I look at a continuous delivery pipeline, and I look into some perspective and see, what would that perspective give to this situation? And I would going to try to talk about industrialization today, which is a part of some other types of products compared to just software, right? And we already talked about this, right? Why do we talk about innovation? Why is there a need for it, right? And what we see happening in the landscape is that we have new types of companies coming in, and they're actually quite good at offering high quality products sort of faster than maybe the established companies are. So there's something happening, right? But it's not only that. It's not only sort of a competitive pressure. We also have a regulatory environment where there are more things coming in, more laws coming in place in a faster pace. And if you want to be in several markets, you have to be able to react to several different markets' regulations, right? To have your product relevant, right? And also we get a lot of new technology, like AI, of course, is the word of the day, right? But also, there's so many new opportunities to add new things to your products compared to maybe just a couple of years ago. Which means that we have shorter product life cycles. And we have also, unfortunately, had to deal with very large, unpredictable market events like COVID, like war, like different types of things, right? So the need to change, to innovate, to solve the situation has increased. Which is sort of mapped by this this is just a graph trying to say that the value of introducing a product earlier to the market that fits this market now. So we have a crisis, and now your product can work in after the crisis. Well, the faster you can get out with the new type of product, the more value you get, the more market share you get. If you can implement new regulatory requirements faster, well, you can again get a higher market share and so on. So these are the type of things that we see more and more, that it's important to be able to respond to the things that are happening in the market. And even if we're just looking for cost reductions, being relevant as in having the right price for the market, being able to implement those cost reductions in a short amount of time would of course make our pricing strategies better and our ability to again take greater market share. And then just playfully with Lego, try to think about some sort of how do we typically do things today? Like if you look into an industry company, well, it's usually sort of like, yeah, we do a concept, we needed this new type of product. We'll make product development, we'll do the design, we have a lot of plans for how this product would look, right? And then we let the supply chain and procurement people trying to figure out how we're going to buy all the stuff that we need to do, right? And then maybe in parallel, but maybe also after that, someone needs to figure out, well, how do we build a factory to actually build this product now that we have everything in place, right? And this could take years. Like if you have a sophisticated product, it takes years to do this. And actually, to be honest, it's sort of institutionalized in our processes that it will take years because we're used to it taking years, and now it has to take years because of all the rules that we put in place for ourselves, right, or processes. And in the end, we get a factory producing the products, customers happy, and we do some Kaizen or continuous improvement of this product or factory or process with what we can. But it's somewhat hard to change these things when we have gone this far. Right? Some people were nodding, so like we're sort of understanding the general idea here, right? So let's look into product development. It's generally considered a complex problem, so it's really hard to predict exactly how things are going to work. We use empirical engineering as when we do iterative development. We try something out, see if it works. Well, didn't. Okay, so let's try something else. We have a hypothesis, and there's a lot of great sort of tools and ways of handling this, right? And Danter's been alluding to a lot of those things, right? So we do this, and while we're doing the design of the product, basically, what will it be? How will it look? What kind of parts it will be in the product, and so on? Trying to anticipate, well, will this be a good thing, like to procure? Are these parts good to include in the product, and will it be easy to manufacture? Again, we're trying to predict the future here, how easy it will be in the upcoming steps in our multi-year thing. So Elon Musk is a controversial figure in general, right? But he stated that the factory is actually the product. Or actually he said, it's really hard to build a factory that is profitable, that produces the right quality, the product that we want to produce. I think this is actually him sitting, being a bit sad about how hard it is to build a factory. Right? So it turns out, it should be obvious, but it turns out if we look at industrialization, that's also a complex problem. If the factory is also a product, right? It's product development again. So it is not just something like, okay, now we have the product design, it's great, just build the factory, it's going to be easy. No, it's actually hard again. So we need to do this with the help of empirical engineering. We need to do it iteratively. We need to try things out because we don't know exactly how we're going to produce this in the best way. We need to try things out. And now we're highly constrained by the product design and the decisions made maybe in procurement and supply chain. So even though we have all these constraints, these heroes try to build a factory. And we get the result that we get. Maybe we can get some feedback into like, could we maybe change the product a little bit? That would be easier to produce. Maybe that's possible. And there's, of course, a little bit of back and forth. But the major problem still exists here, right? It's a fundamental problem. And it's mainly a sort of a mindset problem. That we think that we can predictably solve a complex problem. We think that if we just have better requirements, better plans, better thinkers, we can predict the future and make a perfect plan. And then this will work. But it doesn't, right? And when we look into complex problems, we need to learn things. Dante just said that, right? We need to be faster in our learning loops. Learn more often, learn more faster. And now we're basically saying, well, if we look at the full product, well, we're sort of learning when we start production. And then we maybe iterate on that, right? That's sort of one learning loop, if we're unlucky, right? So we need to focus on this and say, all right, so we have complex problems. We need to have validated knowledge. We need to create knowledge, basically, out of the chaos or complexity in our marketplace and all the technical opportunities we have and so on. We need to state what this is something we know now. We tried to build something, and now we know that at least this works, or we know that it doesn't work. And you can call it different things, scientific thinking, plan, do, check, act, and so on, right? But we need to have these cycles that lands in some learning. So that's what we're looking for, right? So what we want to do is create knowledge faster. So instead of this years over here, what about at least months? What about weeks, days, hours? How can we move in the direction of learning more often and faster? By actually verifying an industrialized product for the qualities that we want it to have. So measure on the result of this full process more often. Because now we have learning, and then we can do something, right? So one way of looking at this would be, okay, so we start out, we think that we have a concept, we want to build this type of product, we try to do a design, we try to find parts that are available, maybe parts that are available right now, that we can try out our assumption about the concept and the product, right? And we might even try to build a little bit prototype production line, and we learn that this doesn't work at all. All right, good. We learned something. We actually had an integration point, right, where we learned that we need to change stuff. We need to maybe go back and reiterate on, is it even this concept that we're going to build? Like we squeeze that, we change that, we change the design, we change the parts we're including, the supply chain, and this time we got a prototype out. And industrialized, produced prototype. And we learned that this can be produced in this way. Well, still not good enough, maybe. We try again. We learn. And at some point, we get an acceptable product that we might even be able to sell to our customers, right? Will this be 4 loops? Will it be 100? Well, it depends, right? And the message is that we need to move in the direction of increasing the number of learning loops that we can have and increasing the stuff that we include in that learning loop so that we're not pushing that risk into the future. Well, someone else will build the factory and take all the risk of this not being producible. Let's try to find that out earlier, right? And in general, I mean, we're basically building knowledge, right? And in a complex situation, you need to take it stepwise. You need to state something from sort of new knowledge becoming known, and you can take the next step on top of that. So that's what we mean by continuous industrialization, right? That it needs to be more continuous. And a pipeline here would be an investment in infrastructure that would help us to do this more often. Because if you only have manual steps along this way, it's going to be quite expensive to do this many times, right? And it's not going to be economically feasible. You won't do it. But if you invest in the processes that make this easier, invest in new type of contracts with your suppliers, and you invest in machinery that can help you verify the product, and so on, and so on, and so on. You can decrease this time of going through the full process. And coming back to what we learned from some DevOps and continuous delivery in software, we had like 3 months to get anything out the door when it comes to software. Because that's where our processes, our tooling, and also a bit of mindset, right? How it works in software. But then we invested in the tooling, in the processes, in the people and the mindset of how we can do this differently. And suddenly we get software out in minutes, hours, days at least. But it's not only about the sort of tooling and the hard stuff. It is also about the notion that we, the people who work with this product, actually works in the same development value stream. That we want to produce this product, not only my part or my little thing. I want to get this learning out there as soon as possible. I want to see that integrated, in this case, a vehicle, to see if it works or not. And I understand that what I do affects my colleagues here, because we're working together. We're not sort of corporate internal enemies. We're working together on getting this out here. Happy customers, right? As soon as possible. So we're building this pipeline together, and we're using it together to gain knowledge together that we then use to make the product better. It is somewhat simplified, of course, right? I just want to add sort of a fundamental sort of concept and question that we're dealing with here. Is that usually the cost of making a change is going up as time goes in sort of the product life cycle, right? The product itself maybe becomes more complicated in a way, right? And also we invested in things that we bought stuff that is expensive to replace and so on, right? So what we want to try to do is bend off this curve and say, what can we do to reduce the cost of change even late in the product lifecycle, so that we can implement this cost reduction into the product when it's actually produced and being sent out to the customers. That we can innovate on the product within some limits, of course, even when we're on steady state ramped production. What do we need to do to make this happen? And as this curve sort of points to, it will probably be more expensive in the beginning because you're building the pipeline, you're investing into the pipeline. But then you get the great returns that you can actually, oh, there's a new regulatory requirement coming in. We want to expand to this market. Well, we can change the product and we can now launch in that country or whatever it is, instead of having to redo the full product whenever those type of things happens. We can react to crisis and different sort of market events, right? Because we invested in that. And of course, it needs to be a need for that in the product that you're building. So, but in an advanced vehicle program, for instance, it's probably worth it, right? Just also want to touch on modularization, which is such a key fundamental way of simplifying these types of very complicated products, right? So you will have a sort of full product continuous industrialization pipeline where you produce an actual full vehicle. But you will also, of course, divide the product into modules where you have teams or teams of teams developing each and every one of these modules. And they will have their own pipeline, their own way of building just our part, our module, and industrializing that. So that's a key component, of course, in parallelizing our development, making sure that we can work several people in parallel, solving different problems within a predefined interface. How will like the engine interact with the battery and so on, and the steering with this and that. Right? And a way of looking at these integration events or the learning events that we have would be to see that the modules, they're developing as fast as they can, but some modules might have some more challenges than the other ones. Right? So in the first sort of full product integration, some of the modules they might just is V0, like version 0. We're just reusing something from another product. Let's take the engine from, I don't know, a car and put into a truck or whatever you do, right? Well, Some of the teams working on other modules, they actually have sort of a version 1. It's not as performant as it need to be a sort of market releasable product, but it's at least something, right? Time goes on, we're all working. Some of the modules are progressing. Some of them have more problems. Sort of what we say, who do we need to help? Can also be a thing here of it. But really just to see the concept that some of the modules might update every time we do an integration event. We'll have that sort of latest version of that module put into to that vehicle, while others might just use the same that we did last time. So don't have to have everything coupled. We can work more independently, right? But we still have the same demand on that the thing that we're getting out of this is a drivable vehicle that is safe to use. So we're not jeopardizing real quality. But we might saying that, well, when it comes to features, they're maybe not as good over here. Like you only see the speed on the screen. You don't see you can't play any games on the screen in the car yet. But as time progresses, the modules are being developed more and more, right? And we will gradually develop features into the product. Just to sort of give brief examples of things that you might have to do to turn your one-shot, we're going to do this one-time type of development into more of a continuous pipeline. Well, you maybe need to work more closely together. Who knows? Maybe there's potential for more modularization in your product. Maybe you need to fundamentally work with suppliers in another way. Have more long-term partnership with some of them, right? So yes, we will buy 1 million parts from you in a year's time, but also next week we need a new design from you, and then the week after that we need a new design from you again. So how can we do that? How we even ask them if it's possible, right? And how can people that work with procurement help us in this instead of being gatekeepers to change, right? Building prototype production lines as we're building the product instead of after the product is sort of designed and been finished, right? Automatic verification of product qualities so that we can do it often. So we make a change and then feel safe that this is still a drivable vehicle, for instance, that we can try out, right? And in production cells, heavy use of digital twins and so on. There's a lot of things that you might consider doing. But if you look at this as a value stream, you will see the bottlenecks and you start working with them. And you can see things that you can change to make things flow faster. So again, there's a need to get into the marketplace faster to capture more value, right? Need to start controlling the cost of change, investing in making sure that it's not skyrocketing. Building learning iteratively by doing increments of fully integrated products. Use the modules to our advantage, right? And in the end, working together, building the continuous industrialization pipeline.